Hello guys, welcome back to Life Technologies channel and thank you for watching. So in our last video on our IPRAN series, we covered some key principles of ISIS design for IPRAN network, and some of the key concepts that we covered included how to do ISIS areas and level design, ISIS network type, the point-to-point and broadcast networks, ISIS authentication for security, how to do the cost planning on your IPRAN network, and even how do you ensure there is connectivity between different ISIS processes from the access to aggregation. So we also discussed route import between access and aggregation processes, plus many other issues that you need to pay attention to when you are doing your IPRAN IGP design. So please remember to watch that video before watching this one so that you have a better understanding of this series. Today we'll be covering part 2 of IPRAN IGP design, where we'll be doing basic configuration, basic ISIS configuration for IPRAN network. And then later, once we have the basic configuration in place, we can implement the advanced features like authentication, route import in our subsequent videos. So please subscribe and stay tuned for more videos on IPRAN series. So this is our topology, and as you can see, we have different nodes in our IPRAN network. We have the aggregation and the core nodes. So for the core nodes, we have RSG1 and RSG2. And then we have aggregation. We have 4 aggregation nodes: SG01, SG02, SG03, and SG04. So the core nodes and the aggregation nodes form our aggregation ring. And in this aggregation ring, we'll be using ISIS 100. So ISIS process 100 will be our aggregation process. And then we have 2 access rings. Access ring 1, which has CSG01, CSG02, and CSG03, which are connecting to SG01 and SG02. So this one forms the access ring 1 and we'll be using ISIS process 20. Then we have access ring 2, which has nodes CSG06, CSG05, and CSG04. And this ring will be using ISIS process 30. So we have 3 ISIS processes, 1 aggregation process and 2 access processes. So the target of this lab is just to do basic ISIS configurations so that we have the basis of doing advanced features of ISIS in our subsequent videos. So the first step before you start configuration or before you start deploying any network, you need to do some basic data preparations. You need to ensure you have the IP addresses, you need to ensure you have the names in place, you need to ensure you have the point-to-point IPs, which ISIS process will be using for these access and aggregation rings, which network types will be using, how do you generate the network entity, from how do you generate the system ID, which cost will you be configuring. So this will be our first step, and as you can see on this slide, we have the data preparation part. So in our data preparation part, we are just coming up with the details or the parameter that we'll be using to do the configurations. So the first part is you need the names. Which names will you be using when you are doing the configuration? Because remember, you have to configure system name, and this system name can be used for other functionalities. So the name, as indicated, we have RSG01, RSG02, and yeah, these are the names that we'll be using for our nodes. Another thing that you need to have is loopback IPs. So as you can see, we have already indicated the loopback IP that we'll be using for each and every node. And loopback IPs, we normally use /32 IPs. Once you have the loopback IPs, the next thing that you also need is the system ID. Remember, we discussed the network entity in our previous video, where you need to have a unique network entity for every node in your network. So how do you generate the network entity? Of course, you have the area address, you have the system ID, and then you have the selector. So the most unique part that you need to generate is the system ID. The system ID will be generated from loopback 0, so that we make it unique. Remember, loopback 0 is always a unique address. So you normally have to generate the system ID from loopback 0 so that it's unique across the network. So how do we generate the system ID? The system ID, we generate it from loopback 0, and the process is very simple. First, you have to extend each part of the IP address to 3 bits. So for example, we have 1.1.1.1.1. We have to extend each part of it into 3 bits. So it will be 001.001.001.001. So you have 3 bits for each part. Once you have extended that loopback 0 IP address into 3 parts, you divide the extended address into 3 parts. Now, instead of having the 4 parts, you've divided them into 3 parts, each of which will be consisting of 4 decimal digits. And the 4 decimal digits will now be our system ID. So if I were to illustrate this, let me just insert here a text box. So we have 1.1.1. We will generate 001.001.001.001. We have 3 bits for each part, and then now we collapse it into 4 parts. So we go ahead and now have 001. If this is 001, 001, 001, then we are now dividing it into 3 parts of 4 bits each, 4 decimals. So we divide it at this place, and then we also break it at this place. So we have 001, 10, 0100, and 1001. So this is how we generate the system ID. We are taking this part, we are making each part, we are taking the loopback 0 IP address, and we are making each part to be 3 bits. Then we are dividing it into 3 parts after making it 3. So this is how we have generated our system IDs that we'll be using in our network. So they will be unique for every network device. And then we have also indicated the ISIS process that we'll be using. For example, on RSG1, we only have ISIS 100. On RSG2, also, we are only running ISIS 100. We don't have any access ring terminating on RSGs. That is always the standard design, that at the end of the day, we don't have any access ring terminating on the RSGs. But in live network, sometimes we have such cases. Then on SG01, we have ISIS 120. Remember, 20 is our access ring 1 ISIS process. Same for SG02. When you go to SG03, we have ISIS 130 for access ring 2. Then for CSGs, these are the data. We have the loopback IPs, we have the system ID already generated, and then we have the ISIS areas. Other parameters, for the ISIS level, we are using level 2. So all routers will be the backbone so that they can be able to exchange the routing information, the LSAs. Then the cost style, we are using wide, just so that we have a wide range of cost value that we can use in our network. Then it's always a good practice to configure the IS name. So for the IS name, we are using the device name. So if it's on RSG1, when we are configuring ISIS, we will set the IS name to RSG01. So when we are checking on another device, it's very easy to identify which device it is. Like when you're identifying that adjacent is, it's very easy to tell that this device RSG1 has appearing to RSG2. So on the ISIS table, you will have RSG2 as the peer. Then the network type, we are using point-to-point. Remember, the essence of using the network type of point-to-point is to improve the network convergence. So when there is an issue in the network, or maybe the adjacency has gone down, we don't need to do the DIS selection. So this one helps to improve on the network convergence speed. So these are just the data that you require when you are to prepare before you start doing your configuration. You need the name, you need the loopback IP, you need to generate the system ID, you need the ISIS areas that we'll be using. You also need the levels, the cost style that we'll be using, the ISIS name, and the network type. Once you have all this data, we can now move to the last stage of this lab, which will be now doing the configurations. So for the configuration roadmap, of course, it's always best practice to first configure the system names on all routers so that you are able to identify which router you are logged in, referring to the device name. So yeah, the first step will be to configure system names, and then we will create respective ISIS processes. So if it's on aggregation node, for example, SG01, in this case, SG01 will have two ISIS processes. We have ISIS 100, we also have ISIS 20. If you go to RSG1, we only have ISIS 100, so you only configure ISIS 100. Then, as you can see in the topology, in the data preparation, we have indicated which ISIS processes will be configured on which device. So once you've configured the respective ISIS process, then you can now configure IP addresses on physical interfaces and loopback interfaces, and then enable ISIS. So step 3 and 4 will be combined together. And that's why we've started by configuring the ISIS process first, so that we don't have to configure IP address just on the interface, and then later we have to again configure or enable ISIS on interfaces. So that's why it's always better to start by creating the ISIS process. Once you've created the ISIS process, now you can do part 3 and 4 at once instead of splitting them into different processes. So once we finish our configuration, we can verify our adjacent status and check the routing table in different ISIS areas. So this is the configuration roadmap that we'll be using for our lab. So for the configuration, we've already prepared and configured the routers. We'll just take a look at the configurations. Let me open the configuration. So on the configuration part, as you can see, we say the first step will be to configure the system name. So we are configuring, for example, on RSG1, we are configuring the system name to RSG01, and then we configure the ISIS process. For this ISIS process, we are using the parameters that we've planned for during our data preparations. The name, the loopback IP, the system ID, and the areas, and even the level, the cost style, the name, and the network type. So we have ISIS 100 on RSG1. We are specifying the level to be level 2, and then we are giving the IS name to RSG01. Cost style, we set it to wide, and then we configure the network entity. That will be the ISIS configuration. Remember, we are just doing basic configuration. Then later we can dive deeper into advanced configurations. Then we start creating the interfaces. We have our loopback 0, we assign an IP address, and then we enable ISIS on this interface. For physical interfaces, we have this configuration. You need to give a description just to be able for ease identification of the connections, and then you assign an IP address, you enable ISIS, and then this is where we specify the network type. Remember, we said we are using the network type of point-to-point. So this will be the standard configuration that we'll be using for all the interfaces. on all the devices. You give a description, you give an IP address, you enable SIS, then you specify the circuit type to be point to point. So if we just go through the configuration on one of the SGs, this is an SG, we give the sysname, we configure SIS process 100, and then we also configure SIS process 20, because this one is interconnecting one aggregation SIS and another access SIS. So that's why we are creating two SIS process, 100 and 20. And you need to be very keen when you are enabling which SIS process should be enabled on which interface. So the same process continues. You configure the interfaces, you enable SIS, you assign IP address, the circuit type, point to point. So these are the configurations that are already configured on the devices, just so that we can save time. And as you can see, they are all almost similar. We are just changing the system IP, the system name, the process number, and interface descriptions, and the SIS process. So these are the configurations. For the CSGs, it's the same. We are giving a system name of CSG09. We are only configuring one SIS process if it's in either process 20 or process 30, and then we are enabling it on the interfaces. So these are the configurations, as you can see, and this one can be, if you want to do a similar lab, you can request the configurations, and yeah, they will be given to you. So once we've done the configurations, we can now log into the devices and try to check the status. This is the topology on ENSP. I think you saw it on the slide. So on this router RSG1, let me just clear RSG1, we can display SIS peer. You see we have 3 SIS peering that are up. We have peering to SG04, SG01, and RSG01, and they are all in SIS process 100. If we check on if we check on this SG01, we display SIS peer. You can see that we have 2 peering in SIS 100 and 1 peering in SIS 20. Similarly, on SG4, we should have display SIS peer. We have 2 peering in SIS 100 and 1 peering in SIS 30. So this confirms that our SIS configuration, our IP address configuration, they are all okay, and it's already in established states. You can also check the SIS interface just to confirm which SIS have interfaces have SIS enabled. This one will also tell you that in SIS 100 we have these interfaces. The state is up, the MTU, the type, the DIS, whether it's DIS or not. Then we have this one interface in SIS 30. One thing you can also do is display SIS peer and do the verbose so that you get more details about the peering. You can see for SIS 30 we have 1 peer, and it's telling you that the area address is 490030, the same we've configured, the peer IP address, the uptime of these SIS, the adjacency protocol is IPv4, and this is the summary, the interface, the circuit ID, the state, the hold time, and the type. It's type layer 2. Remember, we are using level 2 for our peerings. So we can also check on this CSG. I'll clear it first. If I display SIS peer, you can see that we have one peering to CSG06. We can do a verbose, and you will get more detail about the ISIS adjacency. We can do display ISIS interface also, display ISIS interface verbose, and from this one you can get more detail about the ISIS interfaces. As you can see, for example, for this interface gig 00, we configured the network type to be point-to-point, so you can see the circuit parameters is set to point-to-point, and the IP address is also displayed. The cost, remember we haven't done any cost configurations, but by default ISIS has a cost of 10, so that's why we have level 1 as 10, level 2 as also 10. The IPv6 cost, we haven't enabled IPv6, but you can see the cost. And then we have the timers, the bandwidth, the value, and many other details that you can check. One other thing that we can check is, remember we have different ISIS processes. So if we check on SG01, we expect to see routes from ISIS 20 and ISIS 100, but we will not get any route from ISIS 30. So if I do display on SG1, I do display IP routing table. As expected, you can see that we've learned the loopback zeros of RSG1, RSG2, SG1 to 4 because they're in the same ISIS process. We have the loopbacks of the CSGs in ISIS 20, but we don't have any routes to the access nodes in ISIS 30, so we are not able to get the routes from this end. If we check on one of the CSG, for example CSG 8, if we display IP routing table, let me just recheck this one on CSG2 to display IP routing table. You can see we only have the loopback IPs of the nodes in these ISIS 20, 7, 8, 9, 14. And then we don't have any, like we are not even learning the loopback 0 of these SGs because they are in different ISIS processes. That's why later we'll do a video on how you can do the route import between these ISIS processes to ensure that you have connectivity between different access, between different ISIS processes, especially between the aggregation and the access, because at the end of the day, we need to ensure that we have communication from the CSG to the RSG. And to be able to do that, you need to do some route import, so that in access ISIS process 20, we have the route to the RSG. Similarly, in ISIS 30, we also need to have the routes to the RSG. So that one can only be achieved through route import. You don't need to use static routes. You can just import routes between the two processes and you'll be able to achieve the objective. So this is it for this video, and yeah, we checked the configuration. These are the configurations. Just a summary, these are the configuration we are using: the process, the level, the name, the cost style, and the network entities. In our data preparation, we prepared all these details so that it saves on time. Then the configuration steps, where you configure the system name, create respective ISIS process, configure IP address on physical and loopback interfaces, enable ISIS on interfaces. We said for 3 and 4, you can do them at once. You don't need to do them separately. And then you check the status. You run some commands to verify that our ISIS is running okay, and we are also able to learn different routes from different processes, or even just within the process. So we have connectivity within each process. We have connectivity in ISIS 30, we have connectivity in ISIS 100, and we also have connectivity in ISIS 30. But we don't have connectivity from ISIS 30 to ISIS 100. We also don't have connectivity from ISIS 20 to ISIS 100. So that one will be discussed in our subsequent videos. And yeah, thank you for watching, guys, and please remember to subscribe to our channel, as we'll be continuing to post more content on IPRAN principles. Thank you, and please again remember to subscribe to our channel. Bye.